Welcome to my channel Chemistry Class. Welcome back to chemistry class, my dear student. I hope you are doing well. So, in the previous lecture, we discussed about pH scale, which explain the acidity of solution or acidic nature of solution. But today, we'll go one step further and discuss another very important topic related to basis, which is pOH scale. But dear student, this scale helps us to understand basic nature or alkaline nature of solution. So let's discuss them step by step. Introduction to pH scale. Introduction, my dear student, just like the pH scale measures the concentration of hydrogen ions, mean concentration of H positive ion, the pH scale measure the concentration of hydroxide ions, mean concentration of H negative ions present in a solution. Both pH and pOH are related, and together they determine whether a solution is acidic, basic, or neutral. Definition of pOH. My dear student, the pOH of a solution is defined as the negative logarithm mean base 10 of the hydroxide ion concentration in concentration of H negative ion in moles per liter. Mathematically, pOH is equal to negative log and the concentration of OH negative ion. Explanation of pH skills. Explanation. If you know the concentration of hydroxide ions mean concentration of OH negative ion in a solution, we can calculate its pOH value using the formula pOH is equal to negative log and the concentration of OH negative ion. Let's take some examples to understand this. First one, of concentration of OH negative ion is equal to 1 multiplied by 10 raised to the power minus 1 m. Then pOH is equal to negative log into, we put the value of concentration of OH negative ion 1 multiplied by 10 raised to the power minus 1, which is equal to 1. So this is strongly basic. The second one, of concentration of OH negative ion is equal to 1 multiplied by 10 raised to the power minus 7 m. Then pOH is equal to negative log and to 1 multiplied by 10 raised to the power minus 7 is equal to 7. It is neutral. And third one, of concentration of OH negative ion is equal to 1 multiplied by 10 raised to the power minus 13 m. Then pOH is equal to negative log into concentration and to 1 multiplied by 10 raised to the power minus 13 is equal to 13, which is strongly acidic. Now, the pOH scale, dear student, the pOH scale also ranges from 0 to 14, but it expresses the basic nature of a solution. So, pOH value, nature of solution examples. So, when pOH value from 0 to 6, then the solution is, nature of solution is basic, mean alkaline. Example, NaOH, KOH. If pOH value is 7, and a nature of solution is neutral. Examples, pure water. A pOH value is from 8 to 14, and the nature of solution is acidic. Examples, HCl, vinegar. Relation between pH and pOH. But if student, in water, the following equilibrium exists. H2O reversibly gap H positive ion plus OH negative ion. The ionic product of water is concentration of H positive ion multiplied by concentration of OH negative ion is equal to 1 multiplied by 10 raised to the power minus 14 at 25 degrees centigrade. Taking the logarithm on both sides, log concentration of H positive ion plus log concentration of OH negative ion is equal to log into 10 raised to the power minus 14, which give negative log into concentration of H positive ion plus the negative log and concentration of OH negative ion is equal to 14. So pH plus pOH is equal to 14. Examples, if a solution has pH is equal to 3, then pOH is equal to 14 minus 3, which is equal to 11, acidic solution. If a solution has pH is equal to 9, then pOH is equal to 14 minus 9 is equal to 5, basic solution. For pure water, pOH, read student, and pure water, concentration of H positive ion is equal to concentration of H negative ion is equal to 1 multiplied by 10 raised to the power minus 7 m. Therefore, pH is equal to 7 and pOH is also equal to 7. Hence, pure water is neutral because both ions are equal in concentration. Representation of the pOH scale. This is a representation of pOH scale. Therefore, and pH scale of concentration of H positive ion increases, then a solution become mostly acidic. If concentration of pOH ion increases, then a solution nature of solution become basic. Relationship between concentration of H positive ion and concentration of OH negative ion. The product of hydrogen ion and hydroxide ion concentrations is constant at 25 degrees centigrade. Concentration of H positive ion multiplied by concentration of OH negative ion is equal to 1 multiplied by 10 raised to the power minus 14. If concentration of H positive ion increases, concentration of OH ion decreases. If concentration of H positive ion decreases, concentration of OH negative ion increases. This means when a solution becomes more acidic, pH decreases and pOH increases. When a solution becomes more basic, pH increases and pOH decreases. Measurement of pOH. Dear student, the pOH of a solution can be found in two ways. First one, by calculation. If concentration of OH negative ion is known, use pOH is equal to negative log into concentration of OH negative ion. The second one, by relationship with pH. pOH is equal to 14 minus pH. Examples. Calculation. Example 1. If concentration of OH negative ion is equal to 1 multiplied by 10 raised to the power minus 4 m, then pOH is equal to negative log and 1 multiplied by 10 raised to the power minus 4 is equal to 4. pH is equal to 14 minus 4, that is equal to 10, basic solution. Example 2. If concentration of OH negative ion is equal to 1 multiplied by 10 raised to the power minus 9 m, then pOH is equal to negative log into 1 multiplied by 10 raised to the power minus 9, which is equal to 9. pH is equal to 14 minus 9 is equal to 5, which is acidic solution. Effect of temperature on pOH. Dear student, higher temperature, the value of the ionic product of water, mean K into W, dissociation of water increases. This means both concentration of H positive ion and concentration of OH negative ion increases. However, the sum mean pH plus pOH is equal to 14 changes slightly with temperature. At 25 degrees centigrade, pH plus pH is equal to 14. At 50 degrees centigrade, pH plus pH less than 14. So, my dear student, this is all about today's lecture on pOH scale. I hope you understand. So, if this lecture will help you, then don't forget to like the video, subscribe to the channel for more chemistry lecture, and share it with your friends. Comment your question below. Take care and see you in the next class, inshallah. Thank you for listening.